Hello, everyone. Welcome to the first talk after lunch. So this is a talk on a project that I'm actually doing with a whole number of people, and I'll introduce the team, hopefully if I have time at the end of the talk. But who am I? I'm an associate professor of computer science at Duke. I actually, that's my day job. I moonlight as a chief scientist of a startup, and what I actually end up doing in my research and even in the startup company is like building tools to help you better manage your big data systems, right? So what I'm here today to talk to you about is a project called BigFrame. And the goal of this project is to help you benchmark big data analytics systems, especially the ones that focus on interactive and real-time analytics. And the difference between many of the benchmarks and the other efforts that you might actually be hearing about is we want to give you a tool that will help you create a benchmark for your own needs. Simplify that process and, of course, run it. And we definitely want to leverage community effort on this, and this is going to be something that's going to be released in the open source pretty quickly. So let me start with a categorization of systems for big data analytics. So this is a categorization that is mostly based on how these systems evolved, right? So arguably, the first systems that made large data analysis, like accessible to a large number of people, were these MPP databases, the massively parallel databases, starting with projects like Gamma in the 1980s. And then sometime in the 2000s, people realized that you could actually build execution engines as well as storage systems that are pretty good at doing SQL-type processing. And then HP Vertica was one of the major systems in that category. I'm calling them the columnar. And at the same time, there was MapReduce, right? And that's why a lot of you are here. MapReduce has become really popular. A lot of systems being built on top of that. But people realized over time that MapReduce, the computational model, may not be the best. So a whole category of data flow systems with more richer computational models based on capturing the underlying data flow actually have emerged. It started, I would say, with the Dryad project from Microsoft, which is now heavily being used as part of the Scope project in Microsoft Bing. And then at the same time at Google, there was Dremel, which then led to many implementations like Impala and Drill, and Spark adopts some of that, and there's a recent Stinger project. So the data flow systems are now becoming very popular. And people realized again that, well, innovating on the computational side is not enough, right? You also need innovations on the storage side, especially systems that can handle all the transactional type of data, the fast reads and writes, provide some transactional guarantees, and be able to do analytics on that data. So this is what led to Bigtable, Megastore, Spanner from Google, and similar systems like HBase and Cassandra. And from the database side, the HANA system, which is from SAP, which can really do the transactions, run transactions, and the analytics on the same system, right? At the same time, people realized that, well, I have many more sources of data, like graph data or data that is continuously arriving. So a lot of specialized systems are getting built, streaming systems, systems that can represent matrices and high-dimensional data in some code formats. And there are these SciDB type of array systems. And well, once you have so many systems, you quickly realize the need to have multi-tenant systems under the covers that can support all of these systems on the top. So Yarn and Mesos and systems like that are becoming very popular, right? So this is the overall landscape. And what does it mean for a big data practitioner, like somebody like you? So, well, one thing it is very good at is you get a lot of power, right? You have so much choice. But you quickly realize that, well, even the really mighty sometimes might be lost and might need a little help, right? So as a practitioner, well, you run into questions like these, right? Which system to use for the app that I am developing, right? A keyword here that I've highlighted is developing. Often, the choice of a system, the choice of how to configure a system might have to be made even before the app has been fully developed, right? At design time. So sometimes, well, you usually start with the features needed, like maybe your application needs to process graph data, right? Even there, you have choices like, should I use a specialized system, or should I use a system like Hadoop, which is probably good at doing many things? Well, that's where everything starts, right? You then start to have many more questions and decisions you have to make. Well, some system might say that it is 40x faster than another system. What does that mean? Does that mean that your app will actually get 40x better performance? Who knows, right? Then there are other factors like resource efficiency, or can the system scale as your app and the data that it needs to process scales. And nobody runs one app alone in a system, right? Many apps might have to run, so things like multi-tenancy are also very important. Well, it starts to become even more complex, right? Many apps nowadays kind of have different components with different requirements. One example, if you want to show personalized ads or personalized content, one part is kind of taking all the data collected about users over a long period of time, building machine learning models based on that. Another part is going to see what is happening now, what are the trends happening now, what are users doing now, and combining that in an interactive fashion and then showing content, right? So this kind of has different sort of properties if you look at those two types of processing you need. Well, you might be thinking, well, maybe well, I have different sort of needs, so I could pick the best of breed system for each need. That is often a very good thing, but maybe your system administrator may not be happy because running many systems, troubleshooting them, configuring them, when things break, how do you fix them, that becomes very hard. And the CIOs are always worried about what is the total cost of ownership. So quickly things become very, very hard. And what makes it easier to make decisions are, well, numbers. If you can associate numbers with many of those decisions, and numbers often come from benchmarks, right? Especially when your app has not been completely built, and things at design time. So one approach to develop benchmarks or find the best benchmark is to, I showed you system categorization, right? I have a nice system categorization, so I could think of a benchmark per system category, which is often a good thing, but sometimes it can actually be not the best thing. Why? Because if you look at the system categorization, and if you look at what is happening in the benchmarking community, there are so many benchmarks to choose from. In the database community, which is really where I come from, the MPP databases and the columnar systems, TPC-H, TPC-DS, these are king, right? But they might not be the best thing for MapReduce systems. So for MapReduce, people developed another set of benchmarks, micro benchmarks. You can choose things like TerraSort and word count and things like that. There are benchmarks like HighBench from Intel, which puts together a good set of such applications. And then in the mixed world, there are benchmarks like YCSB and its variants, especially something called CH benchmark, which enables you to kind of really benchmark systems which process mixed workloads, transactional as well as analytics. For the specialized systems, there are so many benchmarks. Linear road benchmark is something that you may not have heard of. It's for the streaming processing systems. So many of them, including for multi-tenant systems. But these are useful, no doubt about that. But the problem with them sometimes, and I'm going to illustrate that with this particular slide, is that sometimes you might miss the big picture. Right? So what the slide is showing is a very interesting fable about 6 blind men and an elephant. So 6 blind men went to see an elephant, and then they all came back with very different thoughts of what the elephant is. One blind man ended up feeling the trunk of the elephant and thought it's like a snake, right? The same thing can happen when you're kind of taking a lot of benchmarks, different benchmarks meant for different purposes, and trying to kind of make any decision based on that, right? You might miss the big picture. Often what you end up missing are where the bottlenecks are, right? And sometimes the bottleneck might be in how you're treating data, the overall life cycle of data. Sometimes it has to be transformed, it has to be loaded, it has to be transferred, and the big cost might actually be there that you might actually miss. Right? And many of these benchmarks don't really deal with resource management. A lot of them run one query at a time. Who runs one query at a time? Right? Which cluster runs one query at a time? Right? So you might end up missing these resource management-related challenges, and you might end up making really bad estimates that could be totally off from the real total cost of ownership. There is another problem, and I'm going to illustrate that with this one code that I mangled a little bit. So I think it originally comes from the Bible. So if you give a man a fish, you feed him for a day. But if you actually give him fishing gear, then you are feeding him for life. Okay? Well, what we say is, well, if you give a man a benchmark, you're probably meeting one of his needs for one period of time. But if you give him a benchmark generator that can kind of generate benchmark based on their needs, then, well, you are solving a very big problem, and that exactly is BigFrame. It is intended as a benchmark generator for big data analytics. And this is, interestingly, it's a very challenging problem. And I'm going to illustrate how we think about the problem and why we think we might actually have a solution that could be built out completely with community effort, right? So how does a user go about using BigFrame? So as you might be a big data practitioner and you have a system that you kind of want to test, and you probably want to kind of find out something about that system, how well it meets your application or deployment needs. You go to the BigFrame interface, and I will illustrate each of these boxes in more detail later on. You go to the BigFrame interface, you work with it, and the output is something which we call the benchmark input format, a BigIf. So the BigIf goes to a benchmark generator. This is really the heart of BigFrame. And I would not diminish the other components, but this is really the heart of BigFrame, right? The benchmark generator takes this input format and then generates a benchmark specification. So that benchmark specification is really the real benchmark that can then be given to a driver, a benchmark driver for the system under test, and the driver will be specific to the system under test. Single system, or if you are combining multiple systems, and the job of the benchmark driver is to take the specification, run the benchmark, and it will also provide some really nice utilities, but it has to do things like verify that the benchmark is being run correctly, and then finally give the results, the benchmarking results to the user. So this is the overall cycle. So let's start to drill down into each of these different modules, starting with actually the benchmark specification. So what is, how do we kind of think about the benchmark for big data analytics? So we think about it in there are 4 components of a benchmark. So the very first component is the data for initial load. So you're going to, the benchmark specification comes with some initial data that has to be loaded in the system. And the data might consist of relational data. It might consist of some combination of relational, unstructured data like text and graph. So that is the data that has to be loaded initially. And then there is a data refresh pattern. So which is also might be a function of the data itself. Like some particular data sets might actually be appended on, like new logs getting added. Some data sets might actually have updates, and some data sets may not change at all during the run of the benchmark. And the third part is what we call the query stream. So query is a word that we tend to use because, well, we come from the database community, but think of a query as really an analysis task. It could be a transformation. It could be a real sort of SQL query sort of thing. But the crucial thing, and why are we calling it a stream? Because there is a temporal dimension associated with it, right? And there are a number of query streams through which these queries come, and they have to be run as part of the benchmark. And the last part is the set of evaluation metrics. And the set of evaluation metrics could also differ based on the benchmark itself, right? So these are the 4 things that capture what a benchmark specification is. So now, what does a user specify so that we can generate a benchmark for their needs, right? So this is where we need to somehow characterize the big data, the set of application needs, so that we can help users generate the best benchmark for their needs. So the way I'm going to illustrate that is by kind of going back to our system categorization. If you really drill down into it and see how these systems evolved, it is true that there are these 3 factors, volume, velocity, and variety, that are really at play, right? Most of the initial work happened because the systems just couldn't handle the amount of data, which is the volume aspect that you had to deal with. And then there came systems because you had to deal with a variety of different types of data, and the relational model was not really good enough. And at the same time, especially because you need real-time and interactive analysis, the velocity, the data, the rate at which data is arriving is also very important, right? So we actually take this, what we build on that. So how do we do that? So basically, a user comes and works with a BigFrame interface, and there are 6 components of the interface. One part is, well, the user can choose what the data variety dimension, what are the different types of data they have, relational data, unstructured data, graph data, and then they can also choose the volume of each of these data sets. Maybe it's very large, maybe it's very small. It's really a fine knob that you can set, but as a simplification, you can think of sort of discretely, right? So one thing I really like to point out to students is, sometimes 10 gigs of graph data can be much larger than 100 gigabytes of relational data, because it's not just the raw size that matters, it's the amount of computation you have to do on it, right? And then the third dimension is the data velocity. So data could be at rest, that's not changing. It could be changing slowly, it could be changing very fast, like you're getting a stream of tweets. So this is the data, volume, velocity, variety dimension. And we have added, we think, 3 other important dimensions to really capture the needs of big data analytics. One is what we call the query variety dimension, right? So what does the query variety mean? Like if you take each of these different data sets, you can, let's say take relational data, right? You can think of sort of the basic operations that people often want to do on top of that data, like joins, like selections, like aggregation. But many people, and that is the micro, like the micro benchmark point in the query variety space. But sometimes you really want to see how an application works, right? Which may then translate down to a lot of these low-level operations. But if you're interested in that, then you have to run applications, and that is the macro part, so the macro benchmark. There are two others, exploratory, that is the query, I think it's getting cut off, I'm sorry about that, the query velocity dimension, where like two interesting points that we pick are exploratory, which is really a human being, like a data scientist, writing a query because they want to kind of learn something about data. They're doing ad hoc analysis, right? But a lot of big data analytics is basically continuous, meaning you have a dashboard where things are getting updated, or you are doing some sort of algorithmic decision making. So these are continuous type of analysis. That is what the query velocity dimension captures. And the last one is the query volume dimension. This is the dimension that captures the actual workload, the concurrency, the different classes of workloads you might have if you have a multi-tenancy sort of a need. So user comes, and we actually have an interface where they can choose these dimensions and generate a benchmark input format. So if you think about it, what we have really done is we have somehow discretized the space of the big data analytics sort of needs into some sort of a discretized space based on the query and the data and the combination of variety, volume, and velocity, right? So once they choose that, what we have to do, what the benchmark generate has to do, is to generate an actual benchmark which will meet their needs. So as I discussed, we have these 4 dimensions that categorize a benchmark: the initial data load, the data and the query sort of refresh patterns, as well as the evaluation metrics. So this is really the big challenge, and the way we address this challenge is by converting the benchmark generation into a search problem over an application domain. Okay? So the way we do that, and I'm going to give you an example of how exactly the current version of BigFrame works, is we have, after a study of many different application domains, we picked one of them. And the application domain we picked is the one that sort of combines this very sort of, I would say, kind of very hot now, one that combines e-commerce type of sales and promotions and that type of data with the social media like influence and sentiment type of data, right? So let me be a little bit more specific. So, and this is exactly how, if you want to add a new application domain into BigFrame, this is how you would go about. We first studied this domain, identified the important source of data in this domain. And it may be the sales you're doing on the web, right? Or the promotions you have. And that would be the relational type of data. You might have text and unstructured data like tweets, or you might have graph data like the follower-followee sort of relationships in a Twitter sort of a setting. So first, understand the source of data. And the more important thing is to understand the types of analysis that you want to do. And as I said, often the analysis on each of these individual sources of data is kind of easy. Just quickly comes off of the application domain. So here what I'm showing is a more complex part. How are people think from an application perspective when combining different sources of data together? So I know you can't read this, but it's, you probably get the point that you can actually have interesting applications. For instance, one that combines the promotions with the web sales to really sort of understand, what was like correlate sales data with the promotions that were offered on items, during specific periods in time, right? And it gets even richer, right? Because you could combine sentiment data. This is, and again, I know you can't read this, but the point I want to make here is you can combine sentiment data, which is kind of processing tweets and that sort of unstructured data, with influence of the tweeters based on their graph relationships and the tweets that are actually sent, which brings in graph analysis, along with more relational data like sales, and then generate a report which kind of says, look, because of the promotions and the sentiments that were happening during that, here's how sales look like, right? So you do this, you kind of analyze the domain and come up with the analysis task. And now, once you have enumerated the space of data and the types of analysis tasks, you can take any need that the user might express and basically kind of do I'm not going to say this is a trivial problem, it is a non-trivial problem, but pretty much search through the space of data and queries and instantiate a benchmark which would best represent the needs that the user has expressed. So this is the overall flow of how BigFrame actually works. Now let me show you some use cases of BigFrame so that you can actually see how you could go about using BigFrame. So here is a very basic use case. Maybe you want to do exploratory business intelligence, right? Where you might have large volumes of relational data, where the real challenge is in dealing with these volumes, and the analysis task might be relatively simple, maybe few joins, maybe a lot of aggregation, some user-defined functions, and you might be thinking, well, I can buy this expensive, massively parallel database, or I can kind of take this really nice open source system like Spark or Shark, and then how do they really compare? All of those decisions that I illustrated earlier on, right? Which is a common benchmarking task, and this is very easy with BigFrame. You actually go to the interface, then make some selections, primarily kind of select that your variety of data is kind of the relational one. You have no velocity, pretty much the data is addressed for this benchmark. Your variety is kind of on the micro side, mostly sort of micro benchmark sort of task on the data sources. And you take a driver for any of these systems. We are building a bunch of them, and basically run the benchmark, and you can get a sense of the performance. You can try to answer that question. But many benchmarks can do that. In fact, the Berkeley BDAS team has released the Berkeley Big Data Benchmark, which can do exactly this. So what are we contributing? What we are contributing is we say this is where everything starts, right? Well, the next thing you might want is basically, look, I have that relation data, but see, I have this big volume of text data and mostly unstructured data, right? So I want to kind of see how the system will be able to deal with the relation type of analysis plus some more complicated sentiment analysis or some sort of text analysis. That is, again, an easy. You just go back to the BigFrame interface, make some more changes, and it can instantiate a benchmark for you from this application domain that we have currently chosen, which will contain more application-oriented type of analysis task, and in this case, a lot of sentiment analysis, right? So that you can now, it becomes easy for you to kind of get the next benchmark and reuse all of the efforts that you did in creating those drivers, which we are kind of doing for you anyway, and running the benchmark itself, right? And running benchmarks is often a very expensive task. Use case 2, but maybe then you say, well, I not only want to do the exploratory sort of analysis, but there are these dashboards that my analysts actually want to see. Like, that is a real use case, right? After exploratory analysis, once you've sort of figured out what you want to do, you kind of want to go and create these sort of dashboards, right? And that is very different, and especially very different from what is the Berkeley Big Data Benchmark and many of the other benchmarks do, because now you're talking about some continuously running activity. And this brings in the velocity dimension. Now you have to think about how the data is actually, the data refresh patterns, how the data is coming, whether data sets are getting updated. And at the same time, you also have to think about the semantics of the query system. What does a continuously running task mean? What should it answer? What should the benchmark do to test that the system is actually doing the right thing? And these are all, again, kind of taken care of you with BigFrame. So we have actually figured out how you can add continuously running queries and the data refresh patterns so that you can take your old benchmarks and add extra features to kind of develop a new benchmark. So this is where the query refresh streams and the data refresh streams are very important. Okay? Well, maybe it's, again, more complex. You might actually have many different sources of data, like the relational and text data, but also sort of graph data. And that is the application that I was actually trying to give you an illustration of. And one question that is getting commonly asked today is, am I better off using a single system? It's kind of a jack-of-all-trades system, but it's there. It can do many of these things like Hadoop, the Hadoop stack. Or do I want to kind of take, for the different needs for different types of data, should I take specialized systems? That's not an easy question to answer, because when you take specialized systems, you might have the overhead of converting data, sometimes moving data from one system to the other. And this is a use case that we are personally very interested in. In fact, this is the one use case which led us to think about BigFrame in the first place, because we couldn't really think of any benchmark out there that would help us answer this question, right? Again, very easy with BigFrame, so you can kind of make some changes to your input specification. In this case, there is more richer types of data, and you're kind of still interested in benchmarking the systems from an application perspective. Right? Use case number 5. So, well, all of those earlier things could have been just run one query at a time, right? And you're probably very interested in how quickly the latency of the system, how quickly can those answers be kind of generated. But as I said, no cluster runs one query at a time, and it's very important to benchmark how multiple applications can run together without really hurting each other, right? Again, with our BigFrame benchmark, this is where the query volume dimension actually comes in. You can kind of, we are still refining this, and I have to admit that this thing has not been completely nailed down, but we are figuring out which are the different options that we actually want to give, because one of the needs that somebody has echoed back to us is, look, I would like to be able to run my queries and my data with the same sort of query arrival patterns and data arrival patterns that, let's say, Facebook is having, right? And there have been studies done to kind of abstract out the different arrival patterns of data and queries at many companies based on trace analysis. And this is, again, we have just figured out the set of like the extensibility APIs and how you can add something like this to BigFrame. And this is definitely going to be there as part of the first version of BigFrame, right? And a very important goal for us with all of this, especially like as we want to take this from a academic project, which is like, started in academia, to something that will be useful to the community. We have spent a lot of time thinking about how we can actually work with the community, right? So we can easily open source it. That is definitely what we are going to do. It's going to be out. In fact, we wanted to have, release it by the Hadoop Summit, but what happened is the systems themselves that we are benchmarking, like Spark, had a lot of evolutions. Like they added streaming, they added extra features for graph processing. So we didn't want to release something which should be from day one outdated. So we are kind of taking a little bit more time to understand them and benchmark it. And we have spent a lot of time thinking about how do you add these, what I call the extensibility APIs, so that others can plug in. And another need that, because we are working with companies like HP, one other need that they echoed back to us is, well, we have some sentiment analysis sort of routines that we have written, but we can never open source it. So, but we would like to be able to use your benchmark, use our closed source systems or our closed sourced applications, and be able to leverage everything that that we are offering as BigFrame. So that is an important challenge that we are working on. So there are a couple of places where it's easy for the community to sort of plug in, and that's how we sort of designed the benchmark itself, or BigFrame itself, adding more drivers for more systems. And especially as applications become richer and you need to work with multiple systems, the drivers themselves will become complex. Utilities. So this is something which I feel very strongly about. Understanding that, let's say, Impala can run 40x faster than Hive is one thing. But often the next thing I'm thinking about is, is that because the systems were not well tuned? Is that because something else was happening? So in my research, have been building a lot of tools to help profile and understand what is going on. So it won't be great if, as a practitioner, your driver could be connected with the profiling tools in the underlying systems, so that you not only get these numbers that is 10x better than B, but you can drill down and see what happened and make a judgment call for yourself whether that is something that should be there or it could actually be fixed. All right? So utilities are another place where the community can actually help us a lot. And the last one, the current application domain that we have was chosen based on studying 5 different application domains. And we are pretty sure that the same work that we did to identify the source of data, the sources of queries, the simple queries, the complex queries, that can be done for other application domains. And one thing which I work on a lot is big data, about the big data system itself, like the logs, like the time series data you are getting, like the, all of these JVM level metrics you are getting, a lot of rich source of data where you want dashboards, you want to do exploratory analytics. So that's an application domain you can actually plug in so that you can instantiate the entire BigFrame pipeline for another application domain. Right? So many ways in which we can work with the community, and one reason I'm here is to get some early feedback on the system before we actually go about doing much more work. But in some sense, it might be a little bit late for that matter, because we already have a lot of things implemented, but I would love to have your feedback on this. So okay, that brings me to my last slide. So what is the net takeaway, right? So the net takeaway is that benchmarks are very, very important. In fact, people have argued that benchmarks often end up creating a field or even shaping the field and how it evolves. So the benchmarking activity is very important. It's a big pain, right? And any work done to kind of remove that pain can actually have a lot of value. So we have a lot of benchmarking work is being done in the big data world, right? And we are trying to create something which is different in 2 specific ways. One thing is, we believe benchmarks have, they mean different things to different people, and they serve different needs for different people. If you are a system administrator versus if you are an application builder versus you are a user of a big data system, often what you want out of a benchmark is different, and that's why what we would like to give you is a benchmark generator. Not one actual benchmark where you may or may not agree that is actually something that is useful to you. So that is BigFrame, and I'll be happy to now take questions. I'm done. Questions? So we are actively working with Spark. So the first release of BigFrame will include drivers for Spark and Hadoop. When I say Spark and Hadoop, I really mean the stacks, not just the Spark system or Hadoop, as well as HANA and Vertica. So we definitely want to work with all of these different systems, and the only thing that needs to change is you need to have a driver for any of these systems to be able to run the benchmark on that. And we will provide drivers for all of these systems. And in some sense, that's the research that we are doing, which motivated a lot of the work. Sometimes I have a data set, should I put it in HBase or in Hadoop? Should I use what column format should I use in Hadoop? Should I put it in Spark and memory? And a lot of such questions. And we hope that such a benchmark will enable you to answer those questions pretty quickly. So that's all part of BigFrame. Yes. I'm sorry if I was not very clear on that. The BigFrame framework will generate the data set. So the benchmark specification includes the data for initial load. So that is the real data for the initial load. You might have graph and text or whatever sort of data. And it will kind of give you the real queries, the actual update patterns on the data, and the evaluation metrics. So we will do all of that for you. Yes? Well, this is part of why we are talking about the extensibility API. So you might have data that you actually want to use, right? Or you might, so the question was, well, in some sense the questions are related. The first question was, will BigFrame actually generate the data, right? Will it generate the queries? It's kind of a follow-up question. And the second question was, what if I have, I'm a particular company and I have my own data and I kind of want to benchmark with it, right? Or I might have my own queries. Or another use case, and I don't want to kind of complicate it right now, but another important use case is, look, I have a system I'm already running, application I'm already running, and I would like to find out how it will run on cluster type B or on the cloud, right? Can you give me a tool that will profile the applications and the queries, and then be able to generate something in the BigFrame framework that matches what I have? This is all part of the research that we are going to do. So the answer to that is, well, yes, we are going to be generating data, because without data, there's nothing you can really do. And in the domains that we are working with, we have some real data sets and some data generators that we are writing in case the real data sets cannot be given. So the extensibility API is because, in this case, you want to be able to plug in your own data or your own code sometimes, or your own queries. So we definitely, that is part of our problem definition. We are including that. Yes.
So will your benchmark framework will work with secure data as well, like HIPAA, or how would it matter? Like, if you're securing a data versus not securing data, the queries run differently, right? How is your benchmark going to be different on those things? Loads versus retrieves.
Yeah, the question is, what about, one big concern that many people have, which I didn't have in the slide, is the security about the data itself, right? You might have certain features that you're doing to keep the data secure, either at the data level or at the analysis and the access level, and that could often have performance impact, right? One question, not in this context, that I've got in the past with Starfish is, somebody told me that, well, look, we are thinking about adding these features for performance-related things, and we really want to find out what is the overhead that is going to add, right? If it's going to add more than X% overhead, then we are probably better off not adding it. So that is not something we have actively thought about. It's not something that is kind of part of, definitely you will not see it in the, BigFrame point 1 that is going to be released. But my take on that will be, at least at the driver level, once we give the specification, if you want to secure the data, you can kind of add in those features and then check with those features added, and without those features added, what will performance be? So in that sense, maybe BigFrame will enable you to kind of get some answers, but I don't have an answer on how, at the evaluation metric level, security and of the data becomes a first-class citizen. That's something we'll definitely think about. Any other questions?
Are you guys planning to add any intelligence to the BigFrame, saying that the performance is because of this particular configuration, maybe telling some suggestions? That would be really helpful, right? Saying increase the JVM heap space or do something like that. Might be crazy, but yeah.
No. I'm an academic, right, at heart, right? So we have done so much work on, you can sort of think of BigFrame as, hey, how could I take out my research to the community, right? We have done a lot of research on visualizing, Hadoop ecosystem, being able to sort of optimize it, automatically come up with configurations that will make things faster at the MapReduce level, at the Hive level, at the pig level. So wouldn't it be great if I could run, like, okay, let me just say another thing. So one big problem that people have with benchmarks is you run a benchmark and you don't know, like you see it processes 10 queries a second. Is that the best it can do? Is that because the system is not tuned well? How do I talk to people and check whether it is tuned well, right? So this is a very big challenge. So that's why you see that utilities bullet down there, the second one from the bottom. We want to hook in all of these other utilities such that as a user of a system, I should be able to run the benchmark and then use these other utilities to kind of tune it so that I will have some level of confidence that what I'm seeing in the system is exactly what it is capable of. So definitely the goal is to include these other tuning sort of tools so that you will become sort of independent. You don't have to rely on others to check, to answer these questions of is this what a system is capable of doing? Or maybe even play with configurations. Yeah.
So I have a question and like a feedback kind of thing. That are you guys planning to release like a use case along with the release of your product? Because a lot of times there are benchmarks available out there, but we don't know like after we get the results how to interpret them. So it would be nice if you can compare any of the existing use case, like comparing file formats or comparing tools. So that would be nice to look at.
Great. So the question is, are you going to release the use cases along with the benchmark itself? So all of these things, which again, you can't read this, right? So these are actual analysis tasks that you want to run in the application domain I talked about. So what we will release along with these drivers I talked about will be actually how you go about implementing these things in HANA or Vertica or Spark or Hadoop. And the reason we are going to do that is because, as I said, one big use of the benchmark, again, being in the academic community and seeing how the TBCH benchmark has evolved and is getting used, nobody is using it, or very few people are using it for actually comparing systems A and B. A lot of people, like, in my classes, I tell students, go look at how the TPCH queries are implemented, because you can learn a lot about how to write a SQL query, how to optimize it, how to create data. So as part of that, we definitely are going to be releasing the code of how to write the queries and the analysis tasks for different systems, because hopefully that's going to be a very educational tool. And it will help people trying to learn systems, and there's nothing better than actually looking at how a specific application is implemented to learn the system pretty fast. So it's all going to be released.
I have another question. So on the flip side, right, now we are talking about loading data into the system. What about, if you use different tools to retrieve data like Tableau and, those BI applications, BI tools we are using right now? I mean, is your framework going to look into those things where, how data is loaded and how it is performing with these different tools? Which one would be better for the organizations when they use this for their needs?
Yeah, so this benchmark, as we are thinking about it, yes, this is probably the picture to illustrate that. So the way we are thinking about the benchmark is really a comparison at a system level. So, the exploratory queries might actually come from a platform or one of those sort of tools. So we are not, right now this benchmark will not be useful to you to kind of check how well they kind of take specifications and are able to, write queries, how fast you can develop your application. But loading data is definitely part of what we are doing. Like once we generate the data, how fast can it be loaded? Now, interestingly, like I kind of flew back from the SIGMOD, ACM SIGMOD conference, which is one of the premier research conferences that is happening. It was in New York City. One of the use cases I learned there, and we had a good conversation, is somebody from NEC has developed a benchmark for what they call evolutionary analytics. So often what happens is like, you are a user, you write a particular query, you explore, and then based on that, you get an idea for writing a different query, right? So they have generated a query patterns for a restaurant sort of a domain where they have come up with like what they model is 8 different analysts doing an exploratory task and refining the queries. So we had a good discussion where it seems like their queries can be added as new, like if you look at the query velocity dimension, we have exploratory and continuous. You could add an evolutionary. So that will be a pattern where we can kind of generate queries that are sort of correlated. You do X and then you do Y, and sometimes if a system can kind of, when it processes query X, it is able to structure the data because query Y might come soon after, which is kind of on the same data, or cache the data, like in memory when a pull query is getting asked. Those systems can do really well. So that's something which we'll hopefully add with their help.
That's a wrap. Time's up.
Thanks, everyone.